Today I am with the lesson Fajans rules of polarization. In this lesson the points to be learnt are melting point, definition of polarization, introduction to Fajans, and finally Fajans rules of polarization with some examples. So let's get started. The very first point is melting point. The definition of melting point is the temperature at which solid substance starts to melt and turns into liquid. That temperature is called melting point. For example, melting point of sodium chloride is 801 degrees centigrade. This is ionic compound and its melting point is comparatively high. Another solid substance, that is water solid, which is actually ice, and its melting point is 0 degrees centigrade. This is covalent compound. So for ionic compound melting point is very high, and for covalent compound this is low, and for water it is 0 degrees Celsius temperature. One thing to be kept in mind, that is from ionic compound to covalent compound melting point decreases a lot. That is, the more the covalent compound, the less the melting point. Let's see the next point. Now the point is definition of polarization. Let's consider an ionic compound, lithium chloride, where lithium is cation and chlorine is anion, that means chloride ion. Let's see the molecule diagrammatically. That means this is lithium ion and this is chloride ion. This is electron cloud of chloride ion. Here minus, here this is plus. When these two ions come closer, then there is originated an attraction force between cation and anion's electron cloud. At the same time, there is created a repulsion force between cation and this nucleus. The net result of attraction and repulsion leads to the displacement of anion's electron cloud towards cation. This movement of anion's electron cloud towards cation is called polarization. And after polarization, the molecule is called polarized molecule. And the power by which cation attracts this electron cloud towards itself, this is called cation's polarizing power. Like lithium chloride, few ionic bonds have partial covalent characteristics, which were first discussed in the year 1923 by physical chemist Fajans. Fajans first discussed the polarization of some ionic bonds in the year 1923. Now let's see a short biography of scientist Fajans. Now the point is introduction to Fajans. The full name of Fajans is Kazimierz Fajans. He was Polish-American physical chemist. He was born on 27 May 1887 and died on 18 May 1975. Lifespan was around 88 years. The movement of electron cloud towards cation That means the polarization, the extent of polarization is explained by some rules. These rules are called Fajans rules of polarization. Now let's see Fajans rules of polarization one by one. Now the point is Fajans rules of polarization. Here the first rule is polarization increases with the increase of charges of cations, and it's a periodic relation. Periodic relation means along a period the change of polarization with the change of cationic charges. Let's take elements of a particular period. That means this is the third period's elements. These elements are the third period's elements. Sodium forms unipositive charge, magnesium forms dipositive charge, and aluminum forms tripositive charge. According to this rule, polarization increases with the increase of cationic charges. Now let's see how polarization increases here in case of aluminum 3+. Let's consider this is sodium plus and this is anion. This is aluminum 3+ and this is anion. Here this is unipositive charge. That means low charge compared to this one. Here 3+. This is high charge. So low charge, low attraction and less polarization. Here high charge, high attraction and more polarization. So that is why in this case polarization will be greater. For example, it forms sodium chloride, less polarization, this is more ionic, and that is why its melting point is very high, that is 801 degrees Celsius temperature. But in this case polarization is very high, that means it attains, this compound attains covalent character like aluminum chloride. Covalent character, less boiling point, that means 190 degree Celsius temperature. And magnesium chloride, which is moderate in polarization, and here melting point is 714 degree Celsius temperature. So more polarization, more covalent in nature and less melting point. Here less polarization, more ionic, high melting point. This is the first rule. That means polarization increases with the increase of cationic charges, and it is explained with the help of melting point. That means the more the polarization, the more the covalent in nature and the less the melting point. Now let's see the second rule. Rule number 2 is polarization increases with the increase of charges of anions. This is also a periodic relation. That means along a period polarization changes with the change of anionic charges. Now let's take elements of a particular period, that means nitrogen, oxygen and fluorine. It forms tri-negative ion, this forms di-negative ion, and it forms uni-negative ion. So according to the rule number 2, here polarization increases, then here, and then fluoride ion. Now let's see why in this case polarization increases. This is suppose cation and this is anion. which is 3 minus charge. That means high concentration of electrons here. And in case of fluoride ion, this is suppose cation and this is anion. Here only one charge. That means in this case concentration of electrons is low, but in this case concentration of electrons is high. And for this reason, to reduce the electron repulsion, electrons move towards the cation here excessively. But in this case, less electron concentration, so it moves towards the cation slightly. So this is the reason. That means high concentration of electrons in anion, a higher movement towards the cation, and in this case polarization will be higher, but in this case polarization will be lower. Now let's see the compound of nitrogen, that is calcium nitride, and compound of fluoride ion, that means calcium fluoride. Here more polarization, more covalent in nature, and less melting point. But in this case, less polarization, more ionic, high melting point. That means 1195 degrees Celsius temperature, and its melting point is 1418 degrees Celsius temperature. So in this case polarization is decreased, more ionic, high melting point, and in this case polarization is increased, high covalent in nature, less melting point. Another point is here, that means calcium oxide. Calcium oxide, its melting point is 2572 degrees Celsius temperature. This is exceptionally very high because here this is 2 plus, this is 2 minus. There is a high attraction between these two ions, and these two ions are octet fulfilled. This one octet fulfilled and this is octet fulfilled. So high attraction, high melting point. Now let's summarize the rule number 2. That means the increase of charges of anions, increase of polarization, and decrease of ionic nature, and decrease of melting point. Let's see the next rule. Rule number 3. Polarization increases with the decrease of sizes of cations, and this is a group relation. That means along a group polarization changes with the change of sizes of cations. Now let's take elements of a particular group. That means second group: beryllium, magnesium, calcium, strontium, barium, and radium. This is radioactive element, so it is kept out of consideration. And the cations are, this is 2 plus, 2 plus, 2 plus, 2 plus, and barium 2 plus. According to this rule, polarization increases with the decrease of sizes of cations. From bottom to top, we know the sizes of atoms is decreased, so its size will be the least, and here its size will be the most. According to this rule, in this case polarization will be the most, then magnesium 2 plus, then calcium 2 plus, then strontium 2 plus, and then barium 2 plus. Now let's see how here polarization is greater. This is barium 2 plus, and this is an anion. This is electron cloud. Suppose this is barium 2 plus, which is larger in size, and this is anion. This is electron cloud, this is electron cloud. Here this is smaller in size, so it will be closer to anion. Now in this case polarization is greater according to rule number 3. This is smaller in size compared to this one, so here the concentration of charge is very high. But this is bigger in size, concentration is less, because bigger in size 2 plus charge, smaller in size 2 plus charge. So here concentration of charge is high compared to this ion. Again, because of its smaller size, it can come closer to the anion's electron cloud compared to this one. So here, because of short distance and high charge density, it can attract this electron cloud strongly. Here charge density is less and the distance is larger compared to this one because of its bigger in size. So attraction is comparatively lower here. So in this case, more attraction, more polarization. Less distance, more attraction, more polarization. Here charge density is less, so less attraction. Distance is more, less attraction, that means less polarization. So here more polarization, and in this case the compound attains covalent character. Here less polarization, compound attains less covalent character. That means here compound remains as ionic character. So this is covalent in nature, less melting point. This is ionic in nature, high melting point. Now let's see. Barium chloride, more polarization, more covalent in nature, less melting point, 405 degrees Celsius. In this case, less polarization, more ionic, and that is why high melting point, that means 960 degrees Celsius temperature, its melting point. So the point is polarization increases with the decrease of cationic sizes. Polarization increases with the decrease of cationic sizes, and it is clarified with the melting points of these ions. Let's see the next rule. Rule number 4. Polarization increases with the increase of sizes of anions. This is also a group relation. That means along a group, polarization changes with the change of anionic sizes. Now let's take elements of a particular group, that is fluorine, chlorine, bromine, iodine, astatine. This is a radioactive element. It is kept out of consideration. It forms unipositive ion, unipositive ion, unipositive ion, unipositive ion. But from top to bottom, the sizes of anions increase. So according to this rule, fluoride, chloride, bromide, iodide. According to this rule, here polarization increases, then here, then here. Now let's see how this series is supported. Let's consider an anion. This is cation and this is iodide ion, which is bigger in size, iodide ion. And another one, let's take, that is cation, and this is anion, which is fluoride ion. This is bigger in size, bigger in size. This is fluoride ion, this is cation. In case of iodide ion, polarization increases according to rule number 4. Here, this is bigger in size, that is why the electron cloud remains at distant place. But here the distance is less. Because of this, in this case the electron cloud is bonded to the nucleus with slight force. But here this electron cloud is bonded to the nucleus with excess force because of its shorter distance. But here it is longer distance. This electron cloud is loosely bonded to the nucleus. But here the electron cloud is strongly bonded to the nucleus. And as a result, here displacement occurs higher, but here displacement occurs lower. So in this case, in case of iodide ion, greater polarization happens compared to this ion, fluoride ion. So this compound of iodide ion becomes more covalent compared to the compound of fluoride ion. So this is more covalent, less melting point. This is ionic, high melting point. Now let's see calcium fluoride, ionic compound, high melting point, 1392 degrees Celsius temperature. And in case of iodide, calcium iodide, it becomes covalent in nature, so melting point is less, 575 degrees Celsius temperature. So the more the polarization, the more the covalent in nature, and the less the melting point. Now let's summarize the rule number 4. That means with the increase of sizes of anions, because of the long distance, more polarization happens here. Let's see the next rule. Now rule number 5. Polarization depends on electronic configurations of cations. If cation's electronic configuration is inert gas configuration, then polarization will be lowered. But if cation's electronic configuration is this type, then polarization will be greater. Now let's see the electronic configuration of sodium plus. In sodium chloride, it is 2s2 2p6, which is octet fulfilled and stable electronic configuration. But in this case, suppose copper chloride, electronic configuration of copper plus is 3s2 3p6 3d9. That is unstable configuration. Now let's see, this is suppose sodium plus, this is anion, this is electron cloud. Here copper plus, this is anion, this is anion electron cloud. This is a stable ion which is octet fulfilled. Electronic configuration is 2s2 2p6. So it has less attraction to the anion's electron cloud. But this is unstable configuration. It has a higher attraction to the announced electron cloud. That is why in this case polarization will be higher, but in this case polarization will be lower. More polarization, more covalent in nature. Less polarization, more ionic. So more ionic, high melting point, that is sodium chloride, more ionic, high melting point, 801 degrees Celsius. High polarization, more covalent in nature. More covalent in nature, less melting point. Here copper chloride melting point is 442 degrees Celsius temperature. So polarization depends on cation's electronic configuration as well. This is all about Fajans rules of polarization. No more today. Thank you very much. Take care.